Hello everyone. In this video I will teach you how to graph the exponential function. In this example we have the x or the variable is in the power, or it's the exponent. That's why we call this exponential function. Then we have the standard form y equals a multiplied by b power x. Of course, we have more advanced formula, but this would be for grade 10. So this is the coefficient, and this is the base. This is the exponent or the variable. Then this base will decide whether our graph is growth or decay. This is growth and this is decay. Okay. Then our graph, if our graph is growth, this base, as you see, when the b is greater than 1, this will be growth. So for this example, we expect our graph to be growth. If it's between 0 and 1, it means it's a fraction, and it's a proper fraction. It's between 0 and 1. So our graph will be decay, and we expect our graph to be like this. Then let's go to how to graph. We need some values to plot, and we can connect them. So for this we will make a table. When you design this table, this will be x and y, and you need to know where to start, where to stop. Actually, our graphs don't stop or end. It goes to infinity unless we have a specific domain, but in our case we will pick some values to connect, and this will represent our graph. So we will always start with -3 and end at 3, and we have, of course, we have explanation for this. But when you take the advanced formula, when we have something with the x, we can change the start and end, but for us we will start always by -3 and we will end at 3. So -2, -1, 0, 1, 2. How to find the values of y? This part by a calculator. Mode, then you choose table, write the function. It's 4 multiplied by the fraction is half, and its power 2x. Then the start is -3 and the end is 3, and we are going step one by one. Then the calculator will give you these values. With -3 it's 32, then 16, then 8, 4, 2, 1, half, 1 over 4. Okay, 32, 4, 2, 1 with 2, sorry, 2 is 1, and this is 3, sorry. One over 2. Now we have some values to graph. At -3 it's 32. It's out our range, so we can estimate value for this -1, -2, -3. So this -3, we can estimate that it's here, and you can ignore this point. We can start by the -2. So -2 is 16, -2 is 16 here, -1 with 8, 0 and 4, 1 with 2, 2 was 1, 3 was half, and so on. If you go on with the points, this would be after the half, it's quarter, 1 over 8, 1 over 16, and so on. We are keep going, keep approaching the x-axis, but the graph with the x-axis, they never intersect. So we are going to decrease the value of y, but this will not be 0 because we are dividing by 2 each time. You can see that it's half. This is half. It means we are multiplying by half, by half, by half, and so on. So after this will be 1 over 4, 1 over 8, and so on. So this will not be 0. Now this is our graph. Okay. So how can you expect from the beginning that this will be a decay? Because the base, is a fraction less than 1. For the second one, it's 4 multiplied by 2 power x. We can change the function to be, okay, we can add this in my calculator. I can add this 4 multiplied by 2 power x. Sorry. Now you can see that the difference between the two graphs, that this is 32, 16, it's decreasing for this example, but it's increasing for this. Only in my calculator I can combine or composite two functions, but in your calculator you will have only one function. So you can make the table vertically or horizontally. Sorry, this is vertically. X and Y, -3, -2, -1, 0, 1, 2, 3. So this will be half 1, 2, 4, 8, 16, and 32. 2 with 16, 1 with 8, then 4, 2, 1, half, and so on. Okay, can you note that this point is the y-intercept, which is 4, and the a is 4, because when you put x equal to 0, this will give you the y-intercept. This also, when you cancel the x, because when x equal to 0, this will be 1, so the y-intercept will be 4. That's why they are passing through the point 0 and 4. You can try this, and this is the right answer. If you're wondering how to graph the small points, when you start with the bigger value of y, which is 4, then you go one step left and half this distance. So if this is 4, half the 4 is 2, so you go 2 steps down. Here it's 2 steps, half the 2 is 1, so we go down 1 step. Half this 1 is half, so we go half. We are always going half the distance, so we will approach the 0, and we can estimate the smaller values. This is everything how to graph the exponential, the examples that we need.